up to this point, the D3M program has used pre-developed and pre-curated data sets. Those called seed data sets and training data sets have existing problem descriptions, target variables identified, and data types identified. Our purpose of this demonstration today with Purdue's ModSquad system is to show you that actual real-world data, which is not pre-annotated, can be used effectively through the TA2, TA3 architecture of the D3M system. This is what we expect to see in the future when D3M systems are deployed and working with actual data. We have here a curation interface that ModSquad has added, and it includes views into Amazon S3 buckets, into NoSQL datasets. NoSQL database is the Mongo instance. Also, you can directly upload data. Here's an upload interface where you can drag and drop from the desktop to make a data set that's then a model can be trained on. We're going to show an example of a geospatial data set. See, this geospatial folder is currently empty, and we're going to fill that with a geospatial example where we're going to do some subsetting. Our belief is that many real-world data sets need a custom interface to allow the user to exploit the fine relationships that are discoverable in this interface. We're using here New York City data because the Phase 2 seed data set suggested a problem around LaGuardia Airport traffic pickups. Let's use Kennedy here since we're doing real data and not pre-prepared data. So here is the black dots show us the area around the Kennedy Airport and the taxi locations. Let's set a date up here to be sort of 2 months. We'll go to the end of February, so we'll have 2 months worth of data. We're going to extract the pickups that came from Kennedy Airport for that first 2 months of the year. There's 35,000 of them. We're going to save those out to be annotated by ModSquad and analyzed. And then down here we have 13,000 messages. We're going to save them out, and I'll show you why in a second. So we have a sample. This interface we can use to cull and change date and types to generate the sizes. So we generated that data set on demand. Let's show you what data set we generated. We look at hourly, the messages, and the taxi pickups. Okay, this is a graphical view of what was just generated in those two files. The blue section is the pickup counts per hour, and the red red trace is the message counts per hour. We'll notice that visually there seems to be a certain amount of correlation temporally about the of how the messages and the volume of pickups go. So we're going to suggest that this could be a good annotation data set to improve the model fit for taxi pickups. So let's go back, now that we've extracted those two data sets, let's go back and take a look. In our data set we have geospatial. We now have those two, the trips and the messages themselves. These are at the individual level. These are individual trips and individual messages. They're not rolled up yet into hourly values. So there's a large table you can see, 34,000 entries. So these are individual trips. Let's aggregate them by running a primitive right here through our TA3 interface. This enables the user to have control over some ETL processes that will help to allow the user's semantic understanding of the data sets to guide the ETL process. We're going to create an output for this. Is just going to call it trips by hour. All right, and this task you can see is now currently running. ModSquad now has a capability of running on demand primitives that are located in a pre-compiled Docker container that runs as one of the components of our system. All right, and then while we're here, let's also do the roll-up of the messages. So selecting the messages and selecting an output name. one of the reasons that we're excited about this is D3M is also curating a very advanced library of algorithms such as outlier detection and normalization and fitness by columns. And so these primitives are available here that can be used through this interface if that's what we choose. But we found that allowing the user to do some ETL here in advance to make sure that it's handled right avoids potentially semantic mistakes that an automated ML system might make. So we now have the messages by hour. Let's take a quick look. And the trips by hour. And there you go. We have per hour just the number of pickups. The system also has now a quick view visualization so that a user can just explore the the sanity. Is this the data set that I thought I had before going through potentially a longer training time? So we're just going to do a quick visualization. Yep, there's the data sets showing the number of pickups aggregated per hour. All right, it's the one that I wanted. Let's move forward now and actually train a model on this one. Now we don't need the geospatial subsetting anymore, so we're going to pass by it, go to a view of tables that are data sets that are available for further exploration. You'll see the messages by hour here. We're going to select that one. Actually, we're going to select the trips by hour, sorry. And we have an augment with Data Mart over here because this data set could be then sent to Data Mart for automated suggestion of additional data sets. This functionality is not complete at the moment yet, but we're showing you how it could be done even at the curation interface or here in the dataset interface. So we've selected that. Now, ModSquad, designed for someone who's not a data scientist, does allow some simple exploration of the values that each variable takes so that a user can understand this problem first one variable at a time and then some relationships in between the variables. This allows us to pick here the target variable. We're going to say number of pickups. We can dynamically choose the target variable and it'll be shown how the target variable relates to the other features in the data set. We're going to go ahead and trade this. And since the user can pick any of those target variables, they can move through and analyze a number of different hypotheses based on the same data set without having to change annotations. All right, here's the results that we received back from training the model. We got a number of submissions and we ordered them in from highest to lowest score, that's comebacks. This is this is a regression on the number of pickups. So we're returning the R-squared value. You can see that the R-squared for the Kennedy Airport pickup estimation alone without being augmented is 60.665. The R-squared returns an answer of between 0 and 1 of how well does a model represent the variation around the mean value. So this gives us this. Now what ModSquad does is once you want to pick one of these, you can go forward and take a detailed look at the model performance. From our statistics background in our team, we believe that really model summary statistics are not enough to deeply understand how a model fits. What we need to do really instead is to explore the details by plotting all the values and taking a look at them. So here we have for each value in that data set the number of pickups. This is the actual number that was in the data set plotted against the residuals, which is the amount of error between the actual value from the data set and what the model predicted. What we're hoping for is kind of points all gathered around a horizontal line here at the residual equals 0, which means it was pretty good. What we're seeing here is relatively well fit for smaller number of pickups, but increasing error that the model has, it diverges away from the actual data when the number of pickups per hour was larger. But we got a value for that. So there's some misalignment of the model for larger values of the number of trips per hour. Let's go back and compare to see if we can get a better result using the augmented data set. So we're going to come here and we're going to pick these. We have the messages and trips by hour, but we need to join them. So we're going to go to the task and say append columns and select those two values in our two data sets, trips by hour and messages by hour, because they have common keys from the date. And we're going to call that output augmented trips. And let's run that join. Okay, now a quick view of that shows us that we have both the number of pickups and the number of messages on our line. All right, let's go forward and train a model using this instead. So we'll go forward here. Here is our augmented trips. We select that one, go forward. You can see the view that there is both the number of pickups and the number of messages. All right, we're just going to go through and pick the number, not the number of messages, but the number of pickups that we want to have for our target variable. And we'll train our model. All right, here are the results. And now if we take a look at our R-squared metric for the top seeded answer, let's compare it to the original one that we had. Here was our previous answer. And with augmentation, we get a higher R-squared score. So this is, instead of 0.665, it's 0.6789. So this model better represents the variations around the mean of the input data set. So we were able to improve the resolution of this, the quality of this model, according to the summary statistic, by doing the data augmentation. So throughout this video, we've demonstrated that there's now a curation interface in ModSquad. We've demonstrated that data sets can be processed raw without needing to be annotated, that we can choose a target variable dynamically, and then we can augment the data set and improve the quality of the model fits.